In this video, I'm going to take the capsule that represents the character in the future when I added the mesh, and I'm going to add an imaginary line that will be the camera boom after that character, and eventually I'm going to add at this corner the camera. The goal is that we can watch this character from behind from a certain distance. But before getting into the details, please like, subscribe, and ring the bell and comment about this progress of the third-person shooter that we are creating. And remember, I'm still looking for a name for this video game. Do you have something that I can use? And don't forget to visit Woolon.com and learn more about the Game Creator Accelerator, my lifetime mentorship program where I will be at your side, developing your skills, but also how to expand your community, your connections, the reach to the recruiters, other studios, and eventually find your independence as a game developer. 1 hour at a time, 1 day at a time. In our previous video, we created this class of shooter character, which is a child of the class character, and we also created a blueprint based on that class. Now we're going to the next step, which is I need to add a camera, but that camera has to be a bit away from the perspective of the player. And because the player is going to be on the space limited by this capsule, I need to add something called a camera spring arm. Important to mention is that if you're working only on blueprints, you could add the component here by just looking for spring arm. This is the component that we are going to control, but in C++. So instead of adding the component directly here with the blueprint, I am going to add it in code. I'm going to create a new private section. And in this one, I want to define the USpringArmComponent, which is named USpringArmComponent. And as you can see, it is not suggested on the Visual Studio. Don't worry about that for a second. Because this will be a pointer, I'm going to name this camera boom, and I have to use the asterisk here. The error that is presented here is because I didn't include a header that will handle this USpringArmComponent. But I don't want to include that inside the header. I want to use it when I need it. And in that case, it's on the implementation. But to solve this problem, I have to do something that is called forward declaration, which is just adding class before the USpringArmComponent. And with that, you're telling to the compiler, believe me, I am going to define this afterwards. But at this moment, I just want you to believe me that I am creating a class and that class exists. If you're beginning in C++, probably for you, that sounds like, what the heck are you talking about, Tony? Because it was the same thing for me. But it is literally that. You are telling the compiler, believe me, I am going to define that afterwards. To keep this in consideration, you can always forward declare types like classes, structs, enums, and functions, but you cannot forward declare variables. Now, what does it mean? It means that this doesn't allocate memory at the moment that you present it on the header. A forward declaration is just a promise to the compiler. So you can see it with this phrase. It is like saying this type or function exists somewhere. I'll give you the full definition later. To explain a little bit about why the variables are not forward declared, because when you do something like this, integer x, you are already allocating memory. The way to solve it in the case of variables, well, it's a little bit tricky. You need to add the command extern. But the problem is that you cannot use the extern inside a class. You have to move this entire line of code outside the class. But I'm not going to use it. Now let's record this change that we did, and let's go back to Unreal and compile. Everything went perfect with the compiler, but we still are not seeing this camera arm. Why we are not seeing this camera arm? That's because even though we declare the camera here, we declare the class, we haven't set first the properties and we didn't add that in the implementation file. So let's start doing the first, which is declaring this as a UProperty. And remember that the UProperty is the way to define properties that you can use in Unreal, in the engine. I'm going to start with visible anywhere, blueprint read only. The category will be, I'm going to call it camera set. And the meta will be allow private access equals true. What is the importance of this meta at the end? Well, as you can see, this camera boom is declared as a private. That means that inside the code in C++, this variable is defined as a private. But I want on the side of Unreal to be able to access this camera boom. The way of doing that is, even though it is declared here as a private, I'm saying that I will allow private access true inside Unreal. Of course, then we're going to play with the other two variables. I explained the UProperty in more detail in other videos, and you can find it in the link in the description. But in simple words, the visible anywhere is telling that this variable of the type UProperty will be visible anywhere. That means in the defaults, aka the archetypes or class defaults, and also in the instances, which are objects that we created based on that class. And the blueprint read-only means that in the event graph, this camera boom will be read-only. Every time you create a property, or in this case, a property of the type SpringArmComponent, and you need to connect this with Unreal and have control or visibility in Unreal, you need to define it first as a UProperty. Beyond the fact that this macro allows Unreal to have control of this, it also handles the garbage collection, and it do it by tracking references to UObjects, Unreal objects. At this moment, I want to introduce another thing related more with C++ than Unreal. The fact that we create a variable like a private variable is because we don't want that parameter to be changed in the future using C++ overall when we are working with other teams. But in many occasions, we want to recover this variable to, let's say, call functions. How can we call the variable, or in this case, this property, the USPringArmComponent, if it is private? First off, we're going to create now a new public section. And in this public section, we will use something called the getters. The getters allow me to have access to this without changing the properties of that variable, class, or whatever you want to call. The way to get the camera boom is, well, first you need to say what is the type of object you're going to receive. And the type object is USpringArmComponent, the pointer, and let's call this function getCameraBoom. And because we are not going to change this camera boom, I can add that the result will be a constant. Now, what will be inside this function? What this function will return? Well, simply return camera boom. Even though the name of this function can be anything, we always refer them as getters, because we're getting one particular object, and that's why we say get and then the name of the class of the object or of the variable that we are going to get, and then we just return that object or that class or that variable. I must add, in reference to the const, that this does not affect in terms of efficiency. It is only like a contract with the compiler stating that this getCameraBoom won't change. And to finish this as a perfect line of code, I will add the force inline. The inline means that the compiler replaces the function call this function call with the function body, which is this section, avoiding the overhead of a call. It is an old practice, but it is also mentioned today that without the force inline, the compiler might inline this function automatically. So it's so small that most compilers will. With force inline, though, you are forcing the compiler to inline it no matter what. This removes any function call overhead. In simple terms, what the force inline does is that when the compiler compiles the code, every time that they found the get camera boom, they will only add this section. Probably you are asking yourself, when is force inline useful in Unreal? Well, it's useful for very small, frequently called functions, which are, for example, the getters, math operations, vectors, accessors. Also, when performance is critical and you don't want the compiler to decide. Unreal uses it in F vectors, F rotators, etc. because those functions are called millions of times per frame. Now let's talk about the downside of the force inline. If you don't use it correctly, you can create code bloat. This is forcing inline everywhere increases binary size. If the operation is simple and small, there is no problem. But if it is complex, it is better not to use it. Just called the function. Let's save. And again, if we go to Unreal, after compiling the code, we still don't have the SpringArm. Why? Well, because we still miss one thing, which was the implementation. So let's go to the shooter character CPP, and we are going to add this inside the constructor. Remember that in the header, you define a function which has the name of the shooter character. This function, which is public, this is the constructor. Go to the constructor, which is this one, and let's start. First, we are going to use the variable we define as the camera boom, and we're going to call a function called create default subobject. This is an Unreal Engine helper function used inside the constructor, and it creates a new subobject of the specified type. What is the type we will use? Is SpringArmComponent. The create default subobject ensures that the component is created with proper memory management using Unreal's UObject system. It is owned by the actor, that will be the shooter character in our case, and it is properly tracked by Unreal's reflection system serialization and garbage collection. But I haven't finished the sentence. Now I have to add a text macro, and I will give to this camera boom a name that will be presented on the blueprint. Let's call it, well, camera boom. This will be the name of the component passed as an F name. Unreal requires every sub-object to have a unique name within its owner, and this is why this parameter is so important. And the text macro ensures that this works for both ANSI and Unicode builds. Putting all this line of code together, we allocate and register a new UsePrintArm component. We name it camera boom, and we store a pointer to it in camera boom variable of your character. Since it is marked as with a UProperty, Unreal will manage the garbage collection, the editor will have editor visibility and blueprint exposure. But at this moment, I just added the camera boom, but I didn't attach it to anything. In my case, I want to attach it to the root component of my blueprint. So let's add another line of code, camera boom, and we're going to call the method setup attachment, and the parameter that we're going to pass is root component, and the root component is the highest level of components in your blueprint. So this will be attached exactly under that component, the root component. And at this moment, our compiler said, this is enough. We have to define what is this camera boom. You told me in the header that with a forward declaration, where is it? Is here, that you're going to tell me what this is in the future. Well, it is time for you to tell me what this is. Some years ago, when we found these conditions, we need to go to the documentation of Unreal and trying to figure out where that is. Today, we have ChatGPT, we have AIs that help us a lot. So just move your mouse over the Use SpringArmComponent and look search online. And you will have a very quick suggestion. In my case, I'm using, I guess it's Bing. Let's see the characteristic here. And what matters is that you are looking for an include that you will add to your implementation. And here you can see it very quick. It's usually very simple to identify because it has the SpringArmComponent in it. So I'm going to copy this and add it after this include. Always add the include after the header corresponding to this implementation file. So if in this implementation file that is called shooter character, my header is the shooter character.h, so add your includes after that call. And magically, we don't have problems any longer with these lines of code. Let's save. Another option could be opening ChatGPT and ask a question like, what is the include I should add to the implementation file for an Unreal project in C++ to use your SpringArmComponent? And it's going to give you a lot of information, but what matters is this line of code, the include that we already added here. Open Unreal and compile. Everything looks okay. And if we go to the base shooter character BP and we compile, now we have the camera boom. You can see it is this red line. For this component of the camera boom, you have several properties that you can play with. I want to bring your attention to this one, which is called the target arm length, because I want to set this value in C++. After the last line, the 14, I'm going to add now camera boom and target, it was target arm length. Here we have it, and we're going to set the value to 400. I finish with F because this parameter is a float, as you can see here. So let's save, compile in Unreal, and compile here again. And now we have that the target arm length is 400. We're assembling our character. I know this takes time, guys, but what matters is that you continue this progress week after week. If you didn't do it, please remember to like, subscribe, and make a comment, and share this with somebody that wants to start their journey in the gaming industry. And don't forget to visit woolen.com and learn more about the Game Creator Accelerator and take my free training today. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.